Set up menu point A, which is device orientation. And my LED is off, looking at the status LED. Well, they also call it black. And black means horizontal, socket in the front. This is the socket. It's horizontal. Horizontal. I moved to menu point B, which is swash plate servo update rate. And it is blue. B blue is 200 hertz, and that's what it should be. Set up menu point C is rudder servo center position pulse length. I'm set on blue, which is 1520 microseconds. And I'll look on my cheat sheet right here, follow it over, 1520 microseconds. Set up menu D, which is rudder servo frequency. I'm flashing blue. Blue flashing is 333 hertz. Look at my cheat sheet. Rudder servo frequency update. Follow it over. I'm blinking blue. 333. Blue flashing. 333. Menu point E is tail rotor endpoints. And what that is this. This is the tail, and in the center is the tail slider. I have an end point on this side and an end point on this side. I can take my stick on the radio like this. Move my stick to the left. That's an end point. Move my stick to the right. That's an end point. The slider is not bottoming out on either the left or the right side. When I push it all the way over to either side, the linkage is not binding. The servo is not buzzing. So I have that properly set up. And that is center. At center, I got a little bit of pitch in the blades to counteract the torque in the main blades. That's normal. Menu point F is tail gyro sensor direction. So, in this picture, if I push the tail to the right, if the blades follow the movement to the right, so if the top of this blade moves that way, top of this blade moves that way, that is wrong. What is correct is when I push the whole tail this way, the top of this blade should move to the left to counteract it, and I'm going to prove it. So here we go. I'm going to push it to the right, and this should angle that way. I'm going to push the whole thing to the right, and the top of this blade should angle that way. And it is. This is correct. I push this to the right, top of this blade angles to the left to counteract it. Here we go again. I'm going to push the tail to the right, the top of this blade should pitch that way. That is correct. Menu point G is swash plate servo center trim. So that swash plate is level. And that's indicated by putting this level device onto the center shaft. And see, I got 3 points there. These 3 points here, there, and the other side over there all touch the bottom 3 points on here, and that signifies that the the swash plate is level. Set up menu point H, and that light is red. Doesn't look red, but it is red with my eyes. Red indicates, this is a Swash plate mixer. Red indicates 120 degrees because I have a servo at 120 degrees apart from each other. Setup menu point I is Swash plate servo directions, and that light is purple. It doesn't show purple, but it is purple. Purple is normal, normal, reverse. And to prove that, when I push the stick, the cyclic stick forward, the Swash plate tilts forward. I release the stick, it slowly returns to center. Stick backwards, it tilts backwards. Released, cyclic to the right, angles to the right. I release, stick to the left, it angles to the left. That is correct. If I was on any other setting here, the Swash plate would not react in the proper directions. Menu point J, cyclic pitch geometry. Some of this may not make sense, but as I read these instructions, and they make sense to me, but as I read these instructions, as soon as I enter menu point J, orient the rotor blades so that they are parallel to the tail boom, and they are. The Swash plate should be in neutral position, and it is. It's level, which is neutral. The blades should have 0 degrees pitch. Blade should have 0 degrees of pitch. This is indicated on top of the rotor head. I moved it all. That's okay. I can put it back. The tail's sticking out a little bit. See a couple lines right here? When they're lined up, that means I have 0 degrees of pitch. And I can prove that by looking at my pitch meter. Number on the left is 0.0. Pitch, when we're looking at this, is this way. The other number is roll this way. We're not concerned about that. There's going to be a little bit of roll because the whole thing angles forward. 0 degrees of pitch. This is the second rotor blade that I rotated around, and it was off by 0.4. And I adjusted that by taking this little wrench that I made, and I adjusted this linkage right here, about half a turn. So both blades are at 0 degrees pitch at the neutral setting at setup menu point J. Just out of curiosity, I rotated the original blade back around. That's parallel with the tail boom, and it's off by 0.1. That's okay. 1/10 of a degree, that's okay. Actually, I just adjusted it out of there, so we're back to 0 on the original blade. I checked the other blade, and it was off a little bit, and I adjusted it, and we're right at 0. This is one of those things you just chase back and forth all the time. So this is good. We're moving on. So then I move the aileron stick, which is this right here. I move it that way until I have exactly 6 degrees of pitch in the blade. And when I get exactly 6 degrees of pitch in the blade, my status LED turns blue. The blue indicates that your helicopter's rotor head geometry is perfect for the use with a flybarless system. Otherwise, if the status LED color is red or purple, or even if the LED is off, this indicates that your helicopter's geometry is not optimal for flybarless usage. Well, I'm blue, and that's good. Push the button to save the configuration and proceed to setup menu point K. So I push the button, and I'm on menu point K. Menu point K is collective pitch, range, and endpoints. Setup menu point K you adjust the maximum desired negative and positive collective pitch. So I move the thrust stick, which is this stick here, all the way up and let it stay there. Now I can increase or decrease the maximum amount of collective pitch. So I can look at my meter here, not my meter, my gauge, my pitch gauge. And I can adjust. So this is maximum throttle, maximum collective. And I can adjust how much pitch I want at maximum throttle. So I'm going to adjust this to 10. Rather than adjust it on camera, I did it off camera because it's really sensitive. I'm at 10. And once I get it to 10, when adjusted to the desired maximum pitch angle, move the thrust stick all the way down and again increase or decrease the collective pitch to the minimum desired value using the stick. So I take this and I'm going to move it all the way down. Back on camera here. All the way down. I'm at -5. And that's what I want. I want a little bit of negative pitch in the main blades in case a wind comes up and I need to bring it down. Otherwise, it'll just kind of hover up there and the fresh air, it'll grab that fresh air and to continue to go up. So I want a little bit of negative pitch when I'm at minimum. And that's what I have down here. Also, LED, when the LED is blue, I'm at positive pitch. When the LED is red, I'm at negative pitch. So here we are, 10 degrees positive, 10.1, that's okay. 10 degrees positive, LED is blue. Blue indicates positive pitch. I go with the stick all the way to the bottom. I'm at -5 degrees pitch. The LED is red because LED indicates negative pitch. LED is positive pitch. That's my writing. Let's double check the paper. So we're at menu point K. LED blue, positive. LED red, negative. Right now I'm at 5 degrees negative pitch. The LED is red. 5 degrees. 5 degrees negative, red. Double check. Red indicates negative pitch. Let's go to positive. 10 degrees positive. LED is blue. Menu point K. LED blue, positive pitch. Menu point K is done. Setup menu point K is where you adjust the maximum possible tilting of the swash plate. And I have that. It's maxed out. I can't make it tilt anymore. And I have a blue light. Status light. That's good. Because blue, the color of the status LED indicates whether the adjustment limit allows sufficient cyclic throw. In the ideal case, the swash plate is limited only to the extent where the status LED still lights blue. Moving on to setup menu point M. This is swash plate sensor directions. So if I tilt the helicopter forward like this, the swash plate has to move backwards. Or I tilt the helicopter forward, the swash plate drops in the rear and the front is pushed up. So pick it up, I tilt it forward, swash plate pushes down in the rear, picks up in the front, and vice versa. The same thing is to be said like this. If the helicopter, if it tilts this way, then the swash plate pushes up on this side and drops on this side. So let's tilt it. Pushes up on the left, down on the right, and vice versa. That is correct.